Bismillah Rahman Rahim. Assalamu alaikum everyone. Today we are going to conduct lecture number 13 of our course Microprocessor System, and today's topic is conditional branching. So let's discuss what is conditional branching. We know that we have already discussed about branching instructions. So what are branching instructions? Branching instructions are those instructions which are used to disrupt the normal flow of program. Okay, to understand once again what is normal flow of program, let's consider that we have a program which is consisting of multiple instruction. Let's say it is instruction 1, it is instruction 2, it is instruction 3, it's instruction number 4, it is no, instruction number 5, and so on. So we know that uh, microprocessor or micro controller CPU execute instruction one by one in a sequential flow. We know that if instruction 1 is being processed by CPU, then instruction 2, which is the next instruction, will be pointed by program counter, or in other words, program counter will have address of instruction 2. And when this instruction finishes, then my CPU fetches this instruction, which is instruction 2, and it goes under the process of execution. And similarly, program counter increment itself and points to next instruction. So this is the normal flow of program. What happens when we discuss branching instructions? We know that, for example, this is our branch instruction. Instruction number 3 is our branch instruction. So what is going to happen, as instruction 3 is executed, we will come to know, okay, this is a branch instruction, and my program counter was pointing instruction 4, but it will not execute it. Rather, the branch instruction will flow or jump the flow and break the flow and jump to another instruction which is not the next instruction. So this is called branching instruction. So let's consider what is conditional branch instruction. Conditional branch instructions are those instructions which jump only when certain conditions are true. So we know that there will be certain condition that will be checked by microcontroller or CPU, and then if that condition is true, then microcontroller will be jumping to specific instruction, not to the next instruction, right? So we know that it is because this jumping phenomena depends upon the program counter. So what happened, uh, if certain condition is true, it changes the content of program counter itself. So what happens, uh, for example, if program counter was pointing to the next instruction, which is instruction number 3, so if the condition defined in the instruction or the conditional branch instruction is true, then what will happen, program counter will change its content. For example, instead of 3, it will point now towards instruction number 100. So how it actually uh, this is how branch instruction or conditional branch instruction forces the content of program counter to be modified, and program flow uh, or sequential program flow disturbs. So let's see what are different conditions which can be present in branch instruction or conditional branch instructions. These are normally dictated by flags. Flags are what individual bits of status register. We know that there are various flags. For example, there is negative flag, there is overflow flag, there is a zero flag, there is a digital carry flag, and there is also a carry flag. So based upon these instructions, or based upon these bits, there are certain conditions which can be checked by microcontroller CPU, and based upon these condition we will be generating various branch. For example, nz equal to 0, it's a condition. So nz will be condition, and that will refer that z is equal to 0. So whenever we say branch nz, that means you will be jumping, or we will be jumping whenever there is z is equal to 0. Similarly, we can have branch z. That means conditional, if z is equal to 1, z is present, or z is equal to 1, or 0 flag is equal to 1, then we will branch. So bz means we need to check whether z is equal to 1 or not. If z is equal to 1, then this condition will true, and branching will be happening, and program counter will be modified. Similarly, you can generate various conditions using other flags. For example, BC for C is equal to 1, BNC for C is equal to 0, and so on, right? So various program application can be there, or various generations can be there, which can be generated based upon the status bits, right? Okay, let's consider the example of conditional branch instruction. So let's read the statement first. So statement says one number is received with the port B. That means this port B will be considered as input port. So a number will be received at port B, and other number is already stored. So another number is stored in the file register location. What location? 01 hex. So there is another number stored which is present in the file register location in 01, right? And write a program. So we have to write a program to display their sum. So what the content of the file register 01 and the port B. I'm sorry, there is a mistake. Let me correct it. So what we have to do, we have to write a program to display the sum of content at sum of the content of 01 hacks and uh, port B, right? And we have to display the content at the output port, which is the port D, right? So port D will serve as what? Output port. So this is not mentioned here. Let's mention here. So port port D is an output port, right? So, and we have to also take care of one thing. It says that if there is a carry, right? So if there is a carry in the summation, then you have to turn on the LED which is connected to RC0. So this is our port C, and this is RC0 pin. So this pin should be output pin, and there is an LED connected to that specific pin. So this is the condition we were talking about. So right now we have to check the carry in the status register. If there is any carry, then we have to calculate that carry. We have to check that carry. If this carry is present, then we have to also turn on this LED. If there is no carry, then we will not turn on this LED. So let's write our code. So first of all, let's define our input and output ports. So move little to working 00 hacks, right? And we will be transferring this information in move working file, press D. So this will make our port D as output port, right? So port D is output, and we will also do the same thing. We will also move working file, press C. So it will also convert port C as output. So we are doing the same thing for the both of the port C and port D, because port C will also connected to the output device, and port D is also connected to the output. So we are sending the same information inside both of these ports. So why we are doing so? So that port D and port C become output. What is the next thing we have to do? We have to receive a value from port B. So every port by default is input port, so we will not define port B as input because by default it is in input mode. Now what we have to do, we have to receive this value in certain register, and then we can add that value with 01 hex, right? So we know that we have instruction by which we can receive by which we can actually move any file register. So we will be using that instruction move F and move F port B. So whatever the information coming from port B, let's say we move it into 00 hex. uh, so sorry, not 00 hex, W. So what will happen in this way, whatever the information coming, it will go to working register. So this is the so now the value which is coming from port B, it is stored now in working register, and next value is stored in 01 hex. I hope you remember the statement 01 hex contain another value. So now we have to add 01 hex file and working register. So how we gonna do it? We know there is instruction move working file, sorry, add working file, which file 01 hex, which is given in the statement, and we are adding it with W, and this time we can save this information in working register or any other register. So let's say we save the information in working register, right? Now here we come to the point. We have to send the result, uh, whatever the summation, into the port D. So we will send move working file port D. So whatever the value stored as sum in working register will go to port D. But one thing we have to check here, if there is a carry, okay, we added working register with 01 hex content. Maybe there is a carry and maybe there is not a carry. So we have to consider this program for the both cases. For example, if there is a carry, right? So branch, we have to use a conditional branch if there is a carry, right? So if there is a carry, what we have to do, we have to also turn on this LED. So let's say branch if there is a carry. So BC means branch if there is a carry. We You have to jump to a label. Let's say we are defining a label ABC. So, and let's say somewhere, okay, let me use this line so that we are separating our two columns. So this is our first column. Yes, this is our first column, and this is our second column. So we will be writing into second column now. So let's say there is a label which is ABC, and after that label, let's say we are writing what we are writing. We have to send uh, we have to turn on this LED. So we will be writing move literal to working, let's say 00. Okay, let me connect in binary 000 001. So only least significant bit or the zeroth position bit is high and rest of the bit are zeros. So we will send this information to port C, right? Move working file and move it to port C. So what happened in this way? Zeroth bit of RC, right? This specific pin of RC will be becoming zero, will be coming high, and this LED will turn on because we will have uh, 1 over here and 0 is here because it is grounded. So circuit will complete and this LED will turn on. But this branch or this specific task will be uh, happening or will be accomplished only while uh, there is a carry. If there is a no carry, so what will be happening? So if there is no carry, right, branch if there is no carry, so we will be jumping to another label, let's say ABC1. So let's say this is our ABC1 over here, uh, ABC1, and in ABC1 we will be writing branch repeat, right? So we will be jumping unconditionally to repeat, and repeat will be somewhere here at the back where we actually collected, where we actually started our code. So our repeat will be somewhere here, repeat. Let's say I just write rep repeat, and this thing I can modify. Let's make it only rep. So I hope you have understand the concept. Let me repeat the complete program. First of all, what we did, we actually configure port C and port D as output. This is the area where we actually perform this output configuration, right? And in this area we actually fetch information from port B to working register and then added this working register with the 01 file x content, and we also move the sum into the port D. This is the area, right? And now these are the two conditional statements. First of all, this condition statement, if there is no carry, so it will jump to ABC1, and ABC1 you go to repeat, and repeat, you will start again from this point, right? This is a point from you will repeat your code, right? This is the point. But if there is uh, a carry, right? So this condition will be false if there is a carry. So you will go to this statement. If there is a carry, you will jump to branch uh, branch if there is a carry. So you can jump to ABC, and in ABC you will perform this task. So one can simply avoid this statement. For example, over here you can simply delete it, because after this you eventually arrive to this specific instruction. So you can actually, sorry, 0 1 apostrophe, yeah, that is the thing I was talking about. So eventually if this condition is not true, then you will arrive to this statement, which is with and which will send this 1 to ports RC0, and this LED will turn on. So I hope you have understand the conditional statement, how conditional statement works. Let's see another example. Okay, let's consider another example of conditional branch. So this is our statement. So what is our statement? It says two numbers are being received from port B and port C. So port B and port C both are input ports, and we are receiving two different numbers from port B. So what we have to do, check if they are equal. So we have to check if these two numbers are equal. And if these two numbers are equal, what we have to do, we have to turn on the LED which is connected to RD0 pin. So this is our RD0 pin, and this is connected to LED. So this LED will turn on whenever these two numbers which are received from port B and port C are equal, and otherwise turn on the LED connected to RD1. So there is another LED which is connected to RD1 pin, so it will be turned on if the number are not equal. So we have to follow the two conditions. If numbers are equal, then we will turn on this LED, and if numbers are not equal, then we will turn on this down LED. So what are the things that we know, that these two LEDs are connected to port D. So port D will serve as output port, while port B and port C will be serving as input port. So let's define our output port first. So move literal to working, let's say 00 hacks, and we will transfer, okay, we will transfer this information to move working file port, sorry, trace D. So this is what why we are doing, to port D, to use port D as output port, right? So this is the reason of this instruction, or this is the configuration of output port. We don't need to configure port B and port C because they are by default in input mode. Now what we have to check, we have to check if the number coming from port B and number coming from port C are equal. So you know that if two numbers are coming and you subtract them, so what will be output if they are equal? They are, if output will be zero if they are equal. So what we are doing, we are developing a logic. We are subtracting one number from another number, and using there will be some new command that we have to use to subtraction command, because we haven't used so far in this course any subtraction command. So we will learn a subtraction command, and we will be subtracting one number from another number if they are equal. So what will be output? Output will be zero. And you know that if output of any arithmetic or logical instruction is zero, so there is a carry, there is a zero flag in status register, right? So there are so many flags present in the status register. So there is a specific flag which is present in the status register. It becomes equal to one whenever the last operation's result is zero, right? So and it becomes equal to zero for non-zero operations, right? So this is the condition or conditional flag that we are going to use. So first of all, let's transfer the information of port B in any file, right? So let's say uh, we transfer this information, move file to file from port B to 01 hex. So one information is right now present in the 01 hex, and next number move file. So port C, whatever the data coming from port C, we transfer it to working register. So what will happen? Port C is transferred to working register. So now one value is stored in working register, right? One value is present in working register, another value is 01 hex. So now we have to subtract from one number to another number. So what we have to do, we have to use a new instruction, and that instruction would be sub working with file, right? What we are doing, subtraction working with file, and we will be subtracting what file 01 hex, or we are comparing working register with 0 and 01 file with working register, and we will store the result in the working register. So let me show you, or let me write for you what will be happening. Whatever the file register, in this case it is 01 hex, it working register will be subtracting from file register 01, and result will go to working register because the destination bit is working. The destination thing we have already discussed in so many instruction like add working file or add working file with carry. So what will be happening, whatever the result stored in 01 hex, the working register will be subtracted from this value, and result will go into the working register. So you know that if they are equal, so result will be equal to 0, and if result is equal to 0, so there will be zero flag high. So we will use branch 0. If branch 0, that means what is the meaning of this instruction? Let me write in comments. If, it means if z is equal to 1, that means 0 flag is high. So what we will be doing, if branch is if it is equal to 1, or if that means two numbers are equal, and we have to turn on the led rd0, right? So we will jump to abc, right? uh, let's say if this condition is not true and we reach to this condition, right? So we will jumping. Yep, now I have created two columns, so let's write abc. So now we are in the ABC stage. That means 0 flag was high, and that means two numbers were equal. So we will write what we will write, move little to working, and that means 0 binary 000 001. That means our least significant bit is 0, sorry, high, and that we will transfer to what? That we will transfer to move working file port D. So in that case, RD0 will become equal to 1, which means this LED will glow, right? But what if that condition is, okay, let me shift that port over here, right? So what if that condition is not true? So what will be happening? This means this condition will not true. So what we will be writing over here, that means we will turn on this second LED. So how we will turn on this LED? Move little to working binary 000 and 001. Sorry, not 110. That means this time we will connect. This time it refers to RD1, right? Because this zeroth bit is not high, but RD1 is high, right? And we will move this instruction or move this data to port D, and in this way, RD1 will become equals to 1, which means this LED will turn on, the second LED, right? So this second LED will turn on. Complete the flow of program. First of all, what we are doing, first of all, we are just making port D as output port, right? Then we are developing our logic, right? This is our logic part where we receive port B and send it to 01, and we receive port C and send it to working register. Then we subtract port 01. Then we subtract working register from 01 and put the result in working register. So if 0 flag is high, that means two numbers are equal. So we will check this condition. If zero flag is high, so then branch to ABC, and in ABC level, what we write, move lateral to fucking 0001. So least significant bit is high, and we move this data to port D, and in this way, this LED will turn on. Right, this LED will uh, turn on this this one, right? But if that condition was not true, over here what will be happening, we will jump to this part, and we will write this data in working register, and this one bit, right, this one bit is high, so that we can send it to port D, and this, in if this is going to happen, then this specific LED will turn on. But what if after it this we will eventually arrive to this state, but this should not be run because this is already run. So what we are going to do here, we will use unconditional branch, which is BRA, right? And we will move it to XYZ, and let's put XYZ over here, XYZ, and then uh, we can just simply terminate our code and assembler directive. So hopefully you have understand. We have two different logics over here. In one case, we will turn on the LED connected with RD0. In other case, we will turn on the LED connected with RD1. So hopefully you have understand this concept. And we have taken two specimen examples of a conditional branch. Okay, that's it from this lecture. If you have any confusion, please post in comment section. Thank you so much for listening.